Okay, we've made it past Easter, and I really, really prayed and hoped a few weeks ago that we would be back together by now. But as you've all heard, the governor has shut down in-class instruction, and we will be doing AMIs for the rest of the school year. We are on day 15 of AMI day 16, but real quick, I want to shoot over to the Lamar website. I've had several parents ask and exactly where to get the AMI packet still, exactly what does it mean by the letter that Mr. Holland sent out. So just a quick recap. You can go to lamarwarriors.org. You can get it on your phone or on your computer or on your tablet, whatever resource you have to get on the internet. Scroll down left-hand side. For all information released from the school, you can click on all Lamar information regarding COVID-19. The latest parent letter release was on April the 9th. I have already downloaded it. And it basically tells us, this is from Mr. Holland, which is the superintendent, Mr. Harris, which is the principal of the high school, Mr. Gordon, who is the vice principal of the district, from Coach Spence, who is the middle school principal, and from Mr. McCarley, who is the elementary principal. It is from all of them. It's the whole district. So don't just think this applies for high school. It applies for them all. And so Mr. Holland and the rest of the administration have set before you and said teachers will continue to do AMI packets for days 21 through 39. Everything that's uploaded for this Friday goes all the way to day 20. For students to maintain their current third 9 weeks grade. So this is about your grade. What are you going to have and what's going to happen when you do these AMI packets? So in order to keep your third 9 weeks grade, you'll need to turn in 10 AMI packets of work by May 1st. Whether that is days 2 through 11, whether that's days 3 through 12 or 4 through whatever, as long as you turn in 10 of any between days 2 through 39, 10 of those by May 1st, you keep your current grade that you had from third 9 weeks. It's just going to go over the fourth 9 weeks. If you want to increase a letter grade, since for students wanting to improve their grade by 1 letter grade, they will need to turn in an additional 10 packets for the grade increase by May 15th. So there's 2 deadlines. First deadline is May 1st. And on May 1st, you are to turn in 10 AMI packets. Any of them, or I should say assignments, AMI assignments. Anywhere from days 2 to 39, you turn in 10, and you will keep the grade that you receive from your third 9 weeks. If you want to increase that grade by 1 letter grade max, so let's say you had a 71 in my class and you want to increase it to a B to an 81, you are to do 10 additional assignments. So to keep your third 9 weeks grade, for your fourth 9 weeks grade, if you had that 71, you only had to do 10, which means you can do 2 through 11, you can do 3 through 12, 4 through 14, whichever 10 you want, turn those in, you keep your 71. You're like, hey, I got time on my hands. I can increase my grade a little bit. You do 10 more. So on top of that 2 through 11 that you did, you now can do 12 through 21, which are 10 more assignments. So in total, you've done days assignments 2 through 21. You turn those 20 assignments in, you have now automatically increased your grade from 71 to an 81. Listen, easiest grade you will ever be able to get. I love it. I think our administration did a great job coming up with this. Now it's your turn. We put it in your hands to complete this. So remember, 2 deadlines. First 10 are due May 1st. Second 10 are due by May 15th. Those who have virtual classes or Arkansas ATU concurrent classes, you need to get a hold of your AP teachers, of your concurrent credit teach center, Mr. Coach, or I call him Coach Metter, or Mr. Harris. That is up to you to finish getting that done. So pretty simple, pretty easy. Hopefully you can get it done. Remember, you can get your AMI package just below back at Lamar Warriors. We are high school, but if you're watching this and you've also got elementary and middle school kids, you can click on those. If you don't have the availability to print off, it's not a big deal. They don't have to be printed off. That's just like what I tell you. Let's say that my assignment for the day, and let's move this over. My assignment for the day is this packet here, this page here. And if you've got a piece of paper at home, hold on real quick. Let me answer my darling child. Carolyn, I'm in the middle of recording. What do you need? Kara? Kara? She's not answering, so she'll have to call me back. Okay, 6.1, net force and Newton's first law. If you cannot print this, get a piece of paper out. That piece of paper, you can put your name, your class, and the AMI day at the top right-hand corner. So today's date, you put your name, you put physical science, and then you would put day 16 at the top right-hand corner. And if you still don't have availability, but you have Google Docs on your phone and you can just share it with me, do it that way. So you need a writing utensil and a calculator. My daughter's called back again. Kara, what do you need?
Sorry, Mom, but you left your rings here and I'm getting a little hungry.
Okay, go ahead and make yourself a sandwich and put my rings in my Joy box, please.
Could I get some chicken nuggets or corn dogs?
Yes, ma'am, you sure can. In the air fryer.
Thank you, Mommy.
Love you.
Love you.
Bye.
Bye.
Okay. It happens. Okay, and then your assignment for today is to read through the practice example problem, which I'm going to do with you like I do every day, and then complete numbers 1 through 6. It's only 6 questions. You can do this. I know you can. Do you need to rewrite the questions? Not necessarily. Would I love for you to? Yes, I would love for you to rewrite the questions and your answers. But if you just cannot do it one more second, write me the answer, please. Okay, so let's look. We have Newton's force and Newton's first law. That's what we're looking at. I taught this during Unit 3 back in October. And so this is just review, and I know you're going to get tired of hearing me say it, but that's all it is. Let's remind ourselves about what Newton said. He said an object at rest is going to stay at rest unless acted upon by an outside force, or an object in motion is going to stay in motion. And that applies to what is called the net force, which is all of the forces put into one. And when all these forces are put into one, then we're saying that that net force is going to stay at 0 if the object is at rest, or if the object is at a constant velocity or a constant speed. So if an object is on the interstate and they are going 72 miles per hour and they stay at 72 miles per hour, they have a net force of 0. So let's remind ourselves, what exactly does that mean? So let's look at this first example at the top. We have 2 little girls pushing a boy in a, let's say, a red wagon. Let's just say that's red. They each have an it says A, and so I read that as acceleration. They both have a force. Let's do this one down here. So this girl has force 1. This girl has force 2. Force 1 is pushing on the wagon. Force 2 is pushing on the boy. But as a whole, we're looking at these forces looking at on the x-axis heading in the right direction, or in a positive vector. Where you have what's called force moving back across it, which is like our air resistance force. And so when these two move across one another, these forces have a balanced force when they meet one another. So that's a balanced force. If one is higher, greater than the other one, then it's an unbalanced force, which means they're a little bit off. Newton said that we want it to stay at a 0 as long as you have, or it's going to stay, not that we want it to stay, it's going to stay at a 0 net force if the two of them are equal to one another. Then we have what is called our y-axis. So look here. We have a W, which we all know is our weight, and then our normal force pushing up against, which is our gravity. So we have the weight of the little boy and the wheelbarrow pushing down, where we have the normal force pushing up against. So our weight pushing down, if we know that we're looking at vectors, which we just did 2 weeks ago, anything going down or south on our y-axis is a negative. Anything going up is a positive. And so our free body diagram is we're saying that we've got a force, and I think this one actually saying it's friction. We've got our friction pushing to the negative, where our 2 forces of the 2 girls are in the positive on our x-axis. Got the normal force pushing up on the on the red wagon, and the little boy's weight and the wagon are pushing down in negative. And so if these all fit together and they're going at a constant acceleration, then it's going to be a net force of 0. There's another example down at the bottom where we've got the adult lady pushing on the child, pushing on him, not the wagon. And her force is in a positive motion, where the friction force of the wheels are in a negative motion, where the weight of the boy is negative and the normal force is positive. And so we can look at these and say that if they're moving, it looks like she's sitting still. If they're at rest, then our net force should be, you said 0, you are correct. Okay, let's remind ourselves, back in October, hey, does everybody remember the yellow Camaro? I remember a bunch of oohs and ahs that day, and people going, that's my dream car, that's what I'm going to have one day. And I hope you do, I really do. But let's look at our x-axis. We have our x-axis, and I'm going to go to the board for this one. So we have our x-axis, and what did we call this? We all think the first force when we're driving behind the wheel is the acceleration force. So this first force, which is going in a plus motion, is called our driving force. And Newton said that there's a balance to them. If there's a balance, then we must have something pushing against it at a negative force, which is going to be our air resistance force. Maybe I should write this here because I'm about to write on top of it. That's his driving force. I promise you it does. Okay, and so that is part of our x-axis forces. Now let's look at our y-axis forces. And anything that's pointing down on the y-axis, we said is going to be a negative force. Because it's negative, what would be pushing down? If you said it's the weight of the car, you are correct. And it's got a balance force that goes against it, which is going to be the normal force. And our normal force is positive. So this is our normal, and I'll just put an F, our normal force. But we also have not only air resistance that pushes on that driving force, but we also have what is called friction. So the friction between the wheels and the road are also going against our driving force. So it's also pushing it. When we put our x's together, our +1 and our -1 put together makes 0. When we put our y-axis together with our normal force and our weight, those two pushing against each other should be 0. As long as this car is moving at a constant velocity. So it's doing 65 miles per hour and it continues, its net force will be 0. When it has acceleration, remember we said its net force would change because we're putting more driving force against the friction or the air resistance. Okay, so let's do the first example together. And I'm going to go back to the board for this one. So the first example says an empty shopping cart is pushed along a grocery store aisle at constant velocity. So remind yourself, it's at constant velocity. Remember Newton said if an object is at motion, it stays at a constant motion, its net force is 0. It asks you to find the cart's weight and the friction force if the shopper produces a force of 40 newtons between the wheels and the floor, and the normal force on the cart is 105 newtons. First thing I'm always going to ask myself when reading a problem is, what am I looking for? What am I wanting to find? And that's why I underlined, we're looking for the cart's weight and the cart's friction force. So the next thing is, if I know that's what I'm looking for, what is given? What is told to me? It gives me my normal force and my drive force. So it said that it produces a force of 40 newtons. I'm going to remind myself it's 40 newtons. And then it says that, oh, I read that wrong. Ignore me, it's little. Just ignore me. The force of 40 newtons between the wheels and the floor is 40 newtons, and the normal force of the cart is 105. So if you said 105, or the normal force, you were correct. If you said driving force was 40, you were correct. This little had a little slip. I can do that. I can slip from time to time. So then, what do we know? We know that Newton's first law says if the cart is moving at constant velocity, the net force is 0. So over here on the left-hand side, the bottom of your screen, I went ahead and I showed a man shopping with an empty shopping cart. So I want to say, what are the forces that are going against him? So I'm going to diagram it. So the first force that I can see is that he is moving. So he has a force going on the x-axis heading towards the right. So he has a positive force moving to the right. But then because he's moving, he has this friction force. And remember, he's inside, so there's really not much air resistance inside of the store. So he's got now this friction force, which is pushing the opposite way, which is going to be a negative. But those aren't the only forces going against him. He also has the weight of the cart. Remember we said weight pushes down. And so if the weight pushes down, we know it's going to be a negative force. And then we always have a normal force pushing up. And I really, again, I'm going to erase this because I'm going to show that the normal force is down here, pushing up. So this is the normal force, and it's going to be a positive. So if it's given to me, my normal force is 105 newtons, I'm going to go ahead and put that down here. And if my driving force, which is his driving force, the shopper himself, has a 40 newton, and it's wanting me to find the cart's weight and the friction force, so now I can do my solution. Remember, if he's at a constant velocity, which it tells us here, he's at a constant velocity, Newton's law says that the cart's velocity's net force is 0. So if I want it to be 0, and I'm looking for first my cart's weight, so my cart's weight for normal force, so I can set it up if you want to look at it as an equation, and I can say that I'm looking for, let's go back here. Where are we at? Cart net force. So if I say that the force of the net equals the weight plus my, which one am I answering first? I'm answering cart's weight. Yes. So the weight against my normal force, and I'm just going to put, let's do F normal. I can insert knowing that this is going to be 0 equals my weight, plus it says that my normal force was 40 newtons. I'm just going to subtract both sides by 40 newtons. And so my weight equals, because it's going to be 40 equals, so it's negative 40 newtons equals W, negative 40 newtons. Just set up the equation. Guys, I really wish I knew a lot of this when I was in college. It would have helped me through physics so much. Then I already figured out for weight, because now we've got weight done, because that's what we were looking for here on that one. Now we need to find the friction force. And if it tells us, oh, Miss Little did that wrong, ignore me. Guys, I really, really need some of my students here. I wish I could call you out by name without getting in trouble. But I was wanting to find F net equals my weight. And it said that normal force was plus 105 newtons. Woo! I had too many carbs over the weekend, which 105 newtons equals W, because this is actually 0 here. So W equals negative 105 newtons. Wow. So I'm just going to do the same thing now, but instead For weight, I'm now going to be looking at my x-axis, which will be the normal force, which will be the driving force. Oh my word, against the friction force. No more cake for this girl. That is literally what I ate all weekend long because it was just so yummy. So I can now say the net force of the driving force, so little d, plus the friction. And so we know that this is going to be equal to 0 equals my driving force of 40 newtons plus my force over here, which that's what we need to solve for. Or I'm going to put my little f here, I'm sorry. So then I'm going to subtract both sides by 40 newtons, and I'm going to say 40.0 newtons equals my f. Oh my word, I apologize. I really, really need some of y'all here to help me out. This is what it's like being in my second hour class because I have to get all the kinks and bugs out. So you're welcome. Okay, so my solution there, weight is negative 105 newtons. It's going against the upward force of the normal force. Friction force is negative 40 newtons. Woo! So now let's do, it then asks for number 1. So that's the example we ran through. Number 1 on practice, I know this goes to number 2, but I wanted to look at number 1 real quick. And it says to identify the forces. So let's say we're looking at number 1. Identify the forces on the same cart. So if we're looking at the forces on the cart, what are all the forces? Which we just did together just a minute ago. We looked at the forces. We said that he has a drive force. So I'm going to put force D. And what goes against his drive force is the friction of the wheels. So we've got friction. So I'm going to say I've got drive force, friction. Remember, he's inside grocery shopping, so there's no air resistance going against him. The cart itself has a weight, and then what balances that weight is the normal force. So then we've got weight, and then normal force. So number 1, we basically did that together on the example, so you should have gotten that pretty easily with number 1. Okay, so now let's look at number 2. This one gets a little bit harder because it talks about changing the friction or changing the surface that the friction is. So it says, while the cart is moving along an aisle, it comes in contact with a smear of margarine, which is butter, that had recently been dropped on the floor. Suddenly, the friction force is reduced from negative 40 newtons to negative 20 newtons. What is the net force on the cart if the pushing force, which is the drive force, remains at 40 newtons? Does the grocery cart move at constant velocity over the spilled margarine? So, what are we looking for? First thing it asks us is we're looking for the net force. So it says, what is the net force on the cart if the pushing force remains at 40 newtons? So we know that this is going to remain at 40 newtons. Does the grocery cart move at constant velocity over the spilled margarine? So now we know what we're looking for. We now have to ask ourselves, what is given? So we know that our friction force is going to reduce from negative 40 newtons to now going to be negative 20 newtons. Okay, what do we know? We still know that Newton's first law says if the cart is moving at constant velocity, the net force is 0. Okay, so let's see if we can answer that question. So the first thing I want to answer is the net force. So in this instance, I still set up and I say that my net force, I'm going to put my net there, equals my driving force plus my friction, because we're looking at only the x-axis. So now I can set up and I can say I'm looking for net force. It tells me that my driving force is at 40 newtons and my friction is at negative 20 newtons. which means that my net force is now at 20 newtons. So my net force did change to 20 newtons. Okay, so next question. Well, if my net force is now changed to 20 newtons, is my cart still at constant velocity? No, there is no way that it's at constant velocity, because in order for it to be at a constant, it has to be at a net force of 0. And we know that our net force has now been increased by 20 newtons. So you need to write in there, show your work for me. It's now at 20 newtons, so if it's at 20 newtons, it's changed the net force. All right, so now your job is going to answer questions numbers 3 through 6. Remember, everything has to stay in the balance. Has to stay in the balance. If you can remember, let's do this real quick. Let me remind you of these. You can remember X and Y axes. So remember, on our X axis, we are looking at the driving force. And I like to put F sub D. And friction, which is just a little f. On our y-axis, you are looking at normal force, which is it F normal, or just F. You don't have to put normal, just put F. Net is F subscript net, and the weight. Set up your equations, because Newton said that if an object is at rest, it stays at rest. It has a force of 0, a net force of 0. So you can say net force equals my driving force plus friction. Net force equals normal force plus weight. These will always equal 0 if it follows Newton's first law. An object at rest stays at rest, or an object in motion is in motion, and they have a net force of 0. Okay. If you're still having problems and do not understand that even after I have gone over it, you can go to the book online and reread through pages 138 through 140. Because tomorrow, we're going to review Newton's second law. Hope you guys are all doing great. Remember, embrace the struggle and let it make you stronger. It won't last forever. All right, have a blessed day.